Hey there, welcome to Pomodoro Joe for Tuesday, October 24th, 2023. Today we're looking at LeetCode problem 515. Find largest value in each tree row. This is a medium problem. Given the root of a binary tree, return an array of the largest value in each row of the tree, 0 indexed. All right, so it looks like we have this tree here, 1 with a left of 3 and a right of 2, and then 5, 3, 9. All right, so first row is 1, second row is 3 and 2, so we return 3, and third row is 5, 3, 9, so 9 is the max there, so we return an array of 1, 3, 9. All right, it looks like that's correct. Okay, this is pretty straightforward. We'll put 25 minutes on the Pomodoro timer and we'll get started. So for this one, we'll just do a level order traversal of our tree. So to do the level order traversal of our tree, we'll basically keep track of each level. We'll have our current level, which is an array of the nodes in the current level. And then we'll have the next level, which is an array of nodes in the next level. So we'll start at our current level and we'll look to the left and right of each node in the current level. And that will tell us what nodes are in the next level. So we'll start here at the root. We'll look left and right and put those in the next level. Then when we're done with this level, we swap out this level for the next level. So this becomes our current level. And for each node, we'll look left and right. And so for 3, we'll put 5 and 3 into the next level. And then for 2, we'll put 9 into the next level. So then we have our next level, which will be these 3. And we'll just keep doing that till we run out of levels. All right, so let's start with some result. We'll have an empty array to start with because we need to return an array here. So we'll return our result at the end. Right. So for level order traversal, we'll have our current level. And for that, we're going to start it with the root. Okay, now while we have some current level, so while current level, we'll just go through every node in this level, we'll check its value, compare it to some max value we have so far for this level, and then when we get to the end of all the nodes, we can actually just store that max value in our result. All right, along the way, we'll also be looking at the left and right nodes of every node in this level, and we'll put those nodes into the next level. So what do we have? I guess we'll need to keep track of our largest value. So the largest val, and I'll set it to negative infinite because I don't really know how big it's going to be, but negative infinite is guaranteed to be not the answer. So I'm setting this to negative infinite now because I'm looking for something that's large. So I want to set this to the smallest value possible so that any value we get will kick us off in the right direction by giving us something larger than negative infinite. All right, and then we're going to need our next level, and we'll set that equal to an empty list to start with. Now, for every node in this level, we'll grab the value out of this node. So we'll say val is node.val. And now we'll just check to see if this value is greater than our current largest value. So I'll just set our largest value here. Let me just copy paste. So our largest value will be the maximum of our largest value, or this value. Okay, and now we'll check this node for a left node and a right node. If this node has a left node or a right node, we'll put those nodes into our next level. So if node.left, then next level, append left. And similarly on the right, if node.right, then next level, append right. So as you see, we're going through this level and we're looking forward to the next level, and we're putting these nodes into the next level. Now, once we've made it through all the nodes in this level, we have two pieces of information here. We have this largest val, and that we can store in our result. And we also have this next level. And for that, we're going to swap out our current level for the next level. So let's see here. We'll just cache out our result. So result.append this largest val. And our next level is going to become our current level, or vice versa. Our current level will become our next level. All right, so we're building up our next level as we go through this level. When we get to the end, we're just going to swap it out. So we'll move on to the next level. That becomes our current level, and we'll just keep going. At the very end, we return our result. All right, let's see how we do. That is not defined. Oh, right. This should be node.left. And similarly, this should be node.right. Try that one more time. All right, seems to work. Let's see how well we do. Oh, this is interesting. So this says this is not a node. Now we're only putting nodes into our list here if they exist. The only one that we're not doing that with is this root node. So it's possible that this root node is actually nil or none. So let's do a check outside here. If not root, we'll just return an empty list. All right, we'll try this again. And we pass. We don't do very well though. We only beat 12% for runtime and 70% for memory, so not a great solution. Let's see what we can do to fix this up. Got our early out here. We could do a couple things. Well, one thing, we don't need this extra val, so we can just do this directly. Actually, let's swap out this max for our own max calculation. So largest val will equal val if val is greater than largest val. Else largest val. Right, node left, node right. Let's try this. All right, that makes a huge difference. Wow, just by replacing that max function with our own max calculation, we go from, what was it, a 12%? So now we go from a 12% to a 93% for runtime and a 99% for memory. So that is huge. Wow, I'm actually super pleased with that. That is pretty awesome. All right, well, I think that's it. So for this one, we'll do a level order traversal. And to do that, we'll basically keep track of our current level. We'll go through every node in our current level. And along the way, we'll build up our next level by looking at every node's left and right node. We build up that next level. At the end, we swap it out with our current level. So our current level becomes this next level, and we move on to the next level and do the same. And we just keep doing that till we run out of nodes. All right. Well, that is it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.